Okay, this is page 5 of the I/O notes, and we are going to talk about polling I/O. So with polling I/O, the idea is that your main application is going to keep checking until it sees that data has been received or you're ready to transmit data, and then it does something with that, as opposed to interrupts, which we'll talk about later. So if you recall, I mentioned so we'll look at the UART0 example again. This is our working example, and we had the line status register. I told you that it was 8 bits in size. So there's bits 1, 2, 3, 4, 5, 6, 7, and bit 0 is the receiver data ready. So this is a status register, and if we see 1, that indicates that data has been received, so we need to read it out of the receive buffer register. If it's a 0, that indicates that there's no data that's been received that we're ready to read. And every time you read data from the receive buffer register, it will clear this bit in the line status register until you receive another bit. And the other bits here mean different things, like an overrun error, a parity error, a framing error. We're just going to ignore those for this example. So to do the polling, let's just write a bit of pseudocode. So I said that we need to wait until we see a 1 in bit 0 of the LSR, and then if we see a 1, we can go ahead and read the data. So we're going to do what's called a busy wait, or a polling loop. So the first thing that we do is read the LSR. I'll write this out in proper C code after the pseudocode. So read the LSR is the RDR bit set, and if yes, then read the receive buffer register. If no, let's number these. 1, 2. If no, go to 1. And if, let's just say that we have a keyboard that's plugged into the serial port, so we're typing, and you might be entering a few characters per second. Your processor runs quite a bit faster than that. The clock is 96 megahertz, so roughly 90 million instructions every second. So it's probably going to check that LSR, the status register, a bunch of times in between each character that's read. So it'll read the data, and then it will do something with that, and then it will go back and wait for another character. So the code that I'm going to show you is from uart.c. And I'm going to show you most of a function that's in there. So it returns a byte, because that's what you receive over serial ports, is 1 byte at a time. I mean, it's receiving 1 bit at a time, but it puts it into a frame, so you get 8 bits total. And this function is called uart receive char. It takes a parameter, which is the port num, and it's uint32 type. And this will be 0 indicates that it is UART0, 1 indicates UART1. In the lab, you set things up so that you output on UART1. So that's the port number that will be used there. So there's a bit of code at the start that I'm going to skip, which just determines which UART we're working with. And then here's the polling loop. So while not LPC underscore UART arrow operator LSR line status register and 0x01. So let's just look at what's going on there. It's going to read the line status register. Remember, we declared that as a volatile, or in the struct it's declared as volatile using that double underscore I type modifier. And so we'll read a byte, and then we're going to do a logical or a bitwise AND with this constant here, which is 0000001. Now, I mentioned this before. In reality, in C, integer literals are actually 32-bit ints, but it will truncate that down to 8 bits. So that's what gets ANDed with the LSR. So when we read the contents of the LSR, I said before that we don't really care about the first 7 bits, but what we want to know is the content of bit 0, which is the receive data ready bit. So we're going to AND that with 0000001, and so that will mask out those bits we don't care about. So anything ANDed with 00, and then what we'll get out here is just this one particular bit. So if the bit is 1, this whole expression, the LSR and 01, will evaluate to 1, and then that's complemented. So remember, 1 is true in C, actually non-zero is true in C. So if that's true, then this not will make it into a false and we'll exit the loop. But if this bit here is a 0, then that expression LSR and 01 evaluates to 0, which is false. You complement that and it's true. And there's nothing else to do in between reads. Well, at least in this code there isn't, in between reads of the line status register. So this is the loop body right here. So this here, it's a single statement. This is the loop body. So it's basically doing nothing. Everything is in the loop condition. It just keeps reading that LSR and checking that one bit to see if it's 0 or 1. So I'll just say if the RDR is 1, then the while condition fails and the loop exits. Okay, so that is the polling loop right there, and then this function wants to return the byte that was just received over the serial port, and to do that it has a second statement, return. This is in brackets. It doesn't need to be, but that's just the way the code is in that file that you use in the projects. So LPC underscore UART arrow operator RBR. That's the data register. That's where the byte will reside that's just been received. And again, when we read that, which is what we're doing when we return that value, we read that register, we return it to the calling code that called this function. That will clear the receive data ready bit. So I'll just add a note to that effect. So reading the RBR clears bit receive data ready in the LSR.